Hello Math 3 and welcome to Unit 6. Here's our first lesson, Lesson 6.1. It's really just review and putting all the various things together that you've covered in Math 1, Math 2, and Math 3. So I'd like you to go ahead and give this first page of the lesson a try on your own. Just pause the video, give it a try, and then come back and watch the video and fill in any of the problems you were unable to do on your own. Okay, so you've done that. Let's go ahead and take a look at some of the key things we should be looking at when we're trying to determine what type of graph we have. You can see we've listed some of the choices from Math 1, from Math 2, and you can see Math 3, we've learned quite a bit. Now the key things I like to look for would be, is the graph a function? Is the graph a one-to-one function? Or is the graph not a function at all? Some of these choices are always one-to-one functions. Some of these choices are always functions. Some of these choices are never functions. And then there's a couple that are kind of tricky. They're sometimes functions, sometimes one-to-one functions. The other thing I like to look for would be if the graph is continuous, or is the graph discontinuous. So I'm going to go ahead and start with that, continuous. Okay. For a graph to be continuous, it means connected. All the points connect. There are no breaks in the graph. It's one solid graph. In other words, you could make the graph by putting your pencil down on the paper and then draw the whole graph without ever lifting your pencil off the paper. If you have to lift your pencil off the paper to draw the graph because it has more than one piece involved, we would call it discontinuous. Okay, so you want to look at a graph and determine, is it continuous or is it discontinuous? Let's go ahead and go through what we've learned in Math 1, Math 2, and Math 3, and I'm going to go ahead and highlight all of the graphs that will be continuous. Okay, so linear graphs, they're always continuous. Okay. Exponential, always continuous. Quadratic, well, that makes a parabola. Those are continuous. Absolute value makes a V. Those are also continuous. Okay. Then we get to step functions. Step functions, hopefully you recall, are discontinuous. You have a lot of individual steps that aren't connected. So there's our first one that's discontinuous. Then we get to piecewise. Piecewise graphs are kind of a grab bag. They could be continuous, they could be discontinuous. So it just depends on the graph. So I'm not going to highlight that one. All right, into our Math 3 choices. Polynomial graphs, they are always continuous. Rational. Hopefully you remember rational functions. Remember, they have vertical asymptotes, they can have holes, so they are potentially many pieces. They are discontinuous. Okay, we have square root graphs, those are continuous. Cube root are continuous. Logarithmic are continuous. Sine and cosine, continuous. Then we get to tangent, cotangent. Remember, those have many pieces, and secant, cosecant also broken up into many pieces. So those both have vertical asymptotes breaking things up. So I've highlighted the graphs that are always continuous. All right, now let's talk about function, not a function, one-to-one functions. So let's see if we can find all of the functions and the one-to-one functions. How about we'll start with one-to-one functions. So I'll go ahead and highlight those a different color. So let's make, go back, highlight continuous, we're yellow. Okay, my one-to-one functions, I'll go ahead and use orange. Now remember, a one-to-one function, that is going to make a graph that passes both the vertical and the horizontal line tests. Because the definition of a one-to-one function means that the inverse of the function will also be a function. That's why you have to pass that horizontal line test as well as the vertical line test. Now, a lot of you might think, oh, linear. Linears are functions or one-to-one functions, but remember, linears can be of the form x equals a number. And of course, x equals a number is a vertical line. So linear is not always a function. Okay, how about exponential? Yeah, exponential, always a function and always a one-to-one function. Okay. Quadratic. Well, quadratic's a function, but it fails the horizontal line test, so it's not one-to-one. Same with absolute value. Okay. Step graphs. Step graphs are functions, but they're going to fail the horizontal line test. Piecewise, again, grab bag, you could have anything there. Polynomial, going to fail the horizontal line test. Again, think of a parabola. Okay, then we get to rational functions. Rational functions, again, they're functions, but they could fail the horizontal line test, so they're not one-to-one functions. Okay, square root graph, all right, that's going to be a one-to-one. Cube root graph, that's going to be a one-to-one. Logarithmic, that's going to be one-to-one. Then we get to sine and cosine. Now, sine and cosine, they are functions, but they are not one-to-one because they fail horizontal line test. Same with tan, cotan, and secant, cosecant. So those are our one-to-one functions. All right, so last thing, let's go ahead and talk about which ones are functions. Always functions. Okay, so what do I have left? Pink. Again, linear, they could be of the form x equals a number, so not always a function. Well, exponential we said is one-to-one. Now quadratic. Quadratic is always a function, so go ahead and mark that. Always a function. Absolute value, a function. Okay. Our step graphs, these are functions. Piecewise grab bag, sometimes functions, sometimes not. Polynomial, always functions. Rational are functions. And of course, those are all one-to-one. Sine, cosine, that's function. Tangent, cotangent, and secant, cosecant, also functions. So that's kind of how I look at the different choices we've covered so far. I categorize them into this function, one-to-one function, not a function, continuous, discontinuous. So having done that, I'm going to go ahead and proceed through the various choices now. So my first graph over here, I see it's continuous. Okay, there's no breaks. I see that in this case it is a function. This is a one-to-one function, but I could turn that and make it vertical, and then it would still be the same type of graph. It just would no longer be a function. So this one, since it's got a constant slope, it's never changing, this is a linear graph. So linear. Okay, our next choice here, we can see this one's curving. And since it's curving, it's clearly not linear. I see that it is continuous, so I'm going to be choosing between the yellow choices. And this one is also always going to be a one-to-one function. So this guy right here is a logarithmic. Okay. Moving on to our next graph. Again, I see it's a continuous graph, so I'm picking one of the yellows. You can also tell this guy right here is going to be a one-to-one, so I'm picking a one-to-one function that is continuous, and I can see it is a square root. Okay, moving on to the next graph over here. This one I can see is the first one that is discontinuous. Okay, I have a lot of unconnected pieces on this graph. Hopefully you remember this because we just covered it in Unit 5, right? This looks like a tangent or a cotangent graph. So this is tan or cotan. Okay, moving on to our next graph, we can see this one is continuous again. However, you can see it's not a one-to-one function. This is one of the choice is that it is a function and it is continuous. This is a polynomial. Okay. Moving on to our next graph over here. This one actually fits under two categories. This is a polynomial, yes, but it's a very specific type of polynomial. This is a quadratic. You can see it's a function, it's continuous. However, it fails the vertical line test, so it's not a one-to-one. Okay, moving down to the next row. Hopefully you remember this one. It's a continuous graph. You could see it's a one-to-one function, and based on its shape, I know it's a cube root. Okay. Moving on to our next graph. This is one of those that you learned way back in Math 1, right? We're continuous here, but our slope is changing. We're curving, and it is a one-to-one function. This is an exponential, and it's showing exponential growth. Hopefully you remember exponential decay as well. All right, now we get to this graph over here. This graph is discontinuous, so I have to be choosing between the discontinuous choices. It's clearly not a step ceiling because I do have some curving happening. It's clearly not rational. It's not tangent, cotangent, not secant, cosecant. So this is how I want you to approach piecewise graphs. I want you to eliminate all of other choices. Because yes, I could make a lot of these piecewise by putting different functions together. However, I only want you to use piecewise when one of the other choices doesn't fit. So this is piecewise. It's the only choice that will fit. Okay, moving on. Down here we see a nice sharp V graph. Okay, there's no curve in this, and that's how I know that it's not quadratic. Since there's no curve, right, I have a constant slope on this side, a vertex, and then a constant slope on that side. I know that this one is an absolute value graph. So it's continuous, it's a function, but not a one-to-one. Okay, on to this graph here. This should look real familiar. We did a whole bunch of these in Unit 5. Nice continuous graph. It's a function, but it fails our fails our horizontal line test. So it's not a one-to-one function. This is clearly a sine cosine graph. Okay, on to the graph on the right here. Discontinuous. Not that many choices up here that are discontinuous. A lot of sections that are horizontal lines. So that tells me this is a step function. Okay, and this particular step function is a ceiling. Okay, on to the last row here. This one is interesting. Looking closely, I can see this is actually continuous. However, if I look at all of my choices that are always continuous, none of them fit. So again, this is a graph that the only way to make it is by putting different graphs together. So this is, again, a piecewise graph. So that's the grab bag of piecewise. We can have a piecewise that is discontinuous. We can have a piecewise that is continuous. We can have a piecewise that's a function. We can have a piecewise that's not a function. We can have a piecewise like this that is a function. We can have another piecewise that's a one-to-one function. So piecewise can be a real grab bag. So always go to piecewise when all other choices have failed. All right, down here we can see we have a discontinuous graph. We can see that we're failing the horizontal line test, but we're passing the vertical. So we have a function that's discontinuous. If you look at our choices up there, not a ton of them, right? It's not a step, it's not tangent, it's not secant. This is a rational function. Hopefully you remember that from last semester, right? It has those vertical asymptotes. All right, bottom right graph. Again, discontinuous. Again, function, but not a one-to-one function. So choosing between our choices, we can see this is a secant cosecant graph. All right, so hopefully you're good at identifying what type of graph you are looking at. Okay, go ahead and try the next page. Pause the video. All right. And now that you've tried it, let's go over our answers. How do you know when you're looking at a linear equation? Okay. Well, I know it's linear because it's continuous. And I know it's linear because it's never curving. Another way to say that is it has a constant slope or a constant rate of change. Okay, that's going to be big when you guys move on to Math 4 and Calculus, talking about rate of change. So linear has a constant rate of change. All right, how do you know when something is exponential? Well, again, exponential is continuous. Okay, it's a one-to-one function. Does it have a constant rate of change? No, it doesn't. It has an accelerating or decelerating rate of change. So the rate of change is changing. So I'll say a non-constant rate of change. I'm running out of room. There's more I want to say. You also, of course, know that an exponential has a horizontal asymptote. I'll squeeze that in up here. Okay. So those are some of the things that I look for to identify an exponential. You can also think about end behavior. Didn't even mention that on linear. Remember end behavior on all of these, right? With exponential, one of your ends is going to go to infinity and the other is going to approach your horizontal asymptote. Okay, moving on. Quadratic. Simple way to talk about that would be, again, continuous. Okay, it's a function, always. Okay. And it makes a parabola. And you can talk about parabolas have a vertex, the end behavior, both ends are going to either infinity or negative infinity, right? There's a lot of things you could talk about with quadratics. Okay, next, absolute value. Very similar to quadratic. A lot of similarities. Continuous function. Not a one-to-one though. Again, fails horizontal line test. The main difference here is the shape. A parabola versus a V. So it's going to have a V shape. Nice, sharp, constant rate of change on either side of that vertex. Okay, moving on to the step function. The step function is discontinuous. Okay, and each step is, of course, a nice horizontal line. So it's made up of a series of horizontal lines. And one of the keys, you might say, well, how do I know if it's step or piecewise? Well, the horizontal lines all have to be the same length, and we need to have the same height in between those horizontal lines. That's what tells me it's a step function and not a piecewise function with multiple linear pieces. Okay, and that brings us to piecewise. How do you know it's piecewise? At this point, I'm just going to say because none of the other choices fit. Okay, because that's the only time I want you to go there. Like I just said, on the step function, you could just have a whole bunch of horizontal pieces and make it piecewise, but I don't want you to go there because that's making it more complicated. And then, of course, you're also avoiding ever learning what a step function is that way. Okay, but a piecewise basically means each piece is governed by one of these choices. So each piece has a different function or equation that governs it. All right, polynomial. How do I know I have a polynomial? Well, it's continuous. Okay. always a function. However, oftentimes it will fail the horizontal line test. Doesn't have to, right, if it's a first degree polynomial. Okay. Next, let's look at rational. How do I know if I have a rational equation? Okay. Rational equations, of course, have discontinuity. Okay. They are functions. Sometimes they're one-to-one, but sometimes they're not. It all depends. They can have holes, but not always holes, right? They can have holes. And they can also have vertical asymptotes. Okay, moving on. Square root. How do I know I have a square root? Well, a square root function, it actually is continuous. One of the keys to notice a square root function is it starts at a single point. Okay. And it also has a changing slope or a changing rate of change. All right, next, cube root. How do I know I have a cube root? Well, it's continuous. It's a function. It's a one-to-one function, actually. Oh, I forgot to write that on the square root as well. Okay, so the cube root is continuous. It's a one-to-one function. And you'll notice with the cube root, again, in behavior on these things, you're going to have one end going to infinity and the other end going to negative infinity. It's basically a sideways S, you might say, if you want to write something like that. Okay, on to logarithmic. Logarithmic is continuous. It's a one-to-one function. And of course, it's the inverse of an exponential. So that's why you'll notice logarithmic and exponential look very similar to each other, but they are inverses. So they are, of course, reflected across the line y equals x. And of course, the rate of change is changing, right? It does not have a constant rate of change. All right, sine, cosine, continuous. It is periodic. It's a wave function. So the graph looks like a wave. All right, tangent, cotangent. This one is discontinuous. Oh, I forgot to write function on the sine, cosine. Okay, tan, cotan. This one is discontinuous. One of our few choices that's discontinuous. Okay. But it is periodic, right? It repeats. And we, of course, have vertical asymptotes. So those are some of the things I look for. And again, don't forget about end behavior, right? The end behavior here, one end will go to infinity, the other negative infinity, and so on. So I didn't really talk much about end behavior. Feel free to fill that in on your own. Not a lot of space for it, though. All right, lastly, secant, cosecant. Again, this is discontinuous. It is periodic. We do have vertical asymptotes. Okay. The way I can tell tangent from, notice I have all the same things written on there, tangent and secant. The way I can tell the difference, of course, is secant's going to make U-shapes, right? Whereas tangent, cotangent's going to look much more like a cubic function, right? It's going to make this type of shape. Okay, let's go ahead and move on to the next section. So go ahead and pause the video, give the next section a try. Okay, so you're back, you've tried the problems. Go ahead and take a look. When I read this, the thing that jumps out at me is as soon as I see interest rate, and interest rate tells me right out of the gates that this is going to be exponential. Okay. Moving on to letter B. This one, oh, I can see that I must have printed off the older version. The new version actually gives you the formula. Once you see the formula, you can see I'm dealing with the cube root, so it's a cube root function. And if we were giving you a test, we would make sure to include this formula so that you would know, oh, okay, it's a cube root function. All right, moving on to the next page. Okay, letter C. I'm standing on the corner and a car passes me at a constant speed. So the car is approaching me at a speed and then it is moving away from me at a speed. So when it's dead even with me, that's kind of creating a vertex. But on either side of that vertex, I have the key word constant speed, or in other words, constant rate of change. So that tells me it's a V-shaped graph. It's an absolute value. Okay, letter D. These are very cyclical, right? The population of wildlife, it's going to move up and down with the seasons. So in other words, it's periodic. And in this case, it is going to be a sine or a cosine graph because it doesn't go off to infinity. Okay, letter E. This, I'm going to call it linear. I mean, technically, it's discontinuous, right? Because if my charge is per minute, right, then I'm having to round things off, right, to the minute. And as I do that, I'm creating discontinuity, or I'm technically making like a step function, right? So technically this is a step function. So if you said step function here, I would be fine with it. If you said linear, I would also be fine with that. So I'll say linear, but it's technically a step function, right? Because for that entire minute, your phi is going to be the same. It's constant for that 1 minute, then it jumps the next minute. So step function is really the best choice there. All right, letter F. This is one that I think might trip a lot of you up. On the surface, you might start thinking, oh, this is a step function because it's jumping, it's jumping, it's jumping. But notice the amount that it's going up by is different each time. So since it's going up by a differing amount each time, I can't use a step function to cover this. And since I can't use a step function, because again, the steps are not the same increments, there's only one way to get here, and that's with our piecewise. Okay. Letter G. One of the key things here is physics, right? Roller coasters are, of course, designed to use gravity for acceleration, deceleration, etc. And so that is, of course, a polynomial situation there, right? Gravity is, of course, a quadratic. Okay, letter H. This one, I wouldn't expect you to know this one, unless you've had chemistry. I think you might cover this in chemistry, but anyway, the acidity level, or pH, this is a logarithmic scale. So if you didn't get that one, I would not be upset. All right, on to our last page. I'm trying to figure out how many pizzas you need to feed everyone at your party. Well, that's of course a step function. You can't buy a partial pizza. So this is again a step. If you want to get technical, it's a ceiling function, right? Okay, letter J. This one is, of course, keyword here, reciprocal, right? The sum of the reciprocals. So we're looking at something like 1 over A plus 1 over B. As soon as I see that, I go, hey, I know what that is. That's a rational function. Okay, next one. This one's a little bit fun. Hopefully you can remember your geometry, right? Area of a circle, right? Area of a circle is pi r squared, right? But this, I want to model the radius. So I want it solved, right? Area equals pi r squared. I want it solved for the radius. So to solve this for the radius, right? The radius squared would be area over pi, and of course I would then have to square root that to solve for the radius. So that tells me I have a square root. Okay, next one, distance and direction of a shadow, right? If you actually stand outside all day and watch your shadow, it'd be real fun and interesting. But you would notice early in the morning, right, your shadow's really long in one direction, and then it slowly gets shorter, 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 and by midday you don't have a shadow because the sun's directly over your head. Then your shadow starts slowly moving the other direction, getting longer and longer and longer and longer. So if you think about the shape that that's making, that's like a tangent or cotangent shape graph. Okay, and on to our last choice. We're throwing a ball in the air. You hopefully did plenty of these types of problems in your math career already. That's going to make a parabola, which is of course a quadratic equation. All right, ladies and gentlemen, that's the end of the lesson. Feel free to go back and watch it again if you need, and make sure you're doing your homework. Thanks a lot.